Compute the inverse of S if S is the 2 by 2 matrix 5 minus 3 minus 2, 7. The basic process for finding an inverse is to make a large partitioned matrix whose sub-collection on the left is the matrix we were looking at, the one S, and whose matrix on the right is the identity. And then to use row reductions to somehow reduce it to have the identity on the left-hand side, and whatever we want as the inverse will appear on the right-hand side. So let's see if we can do this. As a start, let's scale these so that the first two entries match. So I'll scale the top row through by a 2 and the bottom row through by a 5. This yields the augmented matrix 10, minus 6, 2, 0 along the top row, and negative 10, 35, 0, 5 along the bottom row. We can now add the top row to the bottom row to come up with 10 minus 10, minus 6 plus 35, which is 29, 2 plus 0, and 0 plus 5. And the top row remains unchanged. It's worth noting that the top row could have been scaled down by a 2. So let's actually do that. Let's keep the numbers small. And so we have this matrix. Now the next thing I'm going to attempt to do is to put a 0 right here. And that will get me fairly close to being in having an identity matrix on the left-hand side. To do this, I want these two numbers to match. So I'm going to scale this row through by 29 and this row through by a 3. And then I'll be able to add the bottom row to the top row. If we do that, scaling the top row through by 29, we're going to have 5 times 29, which is 145, 3 times 29 negative, which is negative 87, then 29 and 0, while the bottom row would become 0, positive 87, 6, and 15. And now we can add the second row to the top row. When we do that, we have 145, 0, 29 plus 6, and 15, whereas the bottom row remains unchanged. Now notice that the bottom row could be scaled through by 1/3. So let's do that really fast. We just recover the previous row. However, the top row could also be scaled down by a 5. So let's do that. That would actually get us a new row here. If we divide everything through by a 5, we get 29, 0, 7, 5, 3. 15 divided by 5 is 3. And then a 0, 29, 2, and a 5. This means we're really, really close to having the left-hand side in augmented matrix form. All we need to do now is scale both rows by 1/29. If we do that, I'm going to put that work up near the top here. We end up with 1, 0, 0, 1, and then we have 7 29ths, 3 29ths, 2 29ths, and 5 29ths. And so this matrix right here is our inverse. In other words, we have S inverse is equal to the matrix 7 29ths, 3 29ths, 2 29ths, and 5 29ths. And since that 1/29th could be factored out of everything, it's preferable and a heck of a lot easier to read by pulling it out and simply writing this as 1/29th times 7, 3, 2, 5. And there's our inverse matrix. And again, it's easy to check that this matrix is right by multiplying these two guys together and seeing if you get the identity. Let's do that quickly. If we take the original matrix times our inverse, I'll pull that 1/29th out into the front. And then let's see, first row dotted with the first column would become 35 minus negative 6, minus 6, which is 29. The second row dotted with the second column would become 15 minus 15, which is 0. The second row dotted with the first column would become minus 14 plus 14, which is 0. And the second row with the second column becomes minus 6 plus 35, or 29. And if I distribute the 1/29th in, we do have the identity matrix. So we see, once again, that the inverse is given by this matrix here.